Okay, this video is about exponential functions. It should be somewhat of a review from Algebra 2 for you. So here we go. Exponential function with a base of a is defined as f of x equals a to the x power, where a is greater than 0, and a is not equal to 1. If 1 is the base and you raise it to any power, you're still going to have a 1. So we eliminate 1, and we say a is greater than 0. X, whatever that power is, has to be a real number. So the parent function of that graph, if you graphed it, does this. If you recall from Algebra 2, it swoops up. So even if, I want you to notice that even if x is a negative number, like let's say for instance my base was 2 and my x was a negative 3. Remember what a negative exponent does? It puts it in the denominator. So really 2 to the third is 8, so that's just 1/8. So while the x value may be negative, the y value is still going to be positive. That's why it's not going to go below that x-axis. Alright, so we're going to evaluate some exponents. It's pretty simple. You're going to use your calculator, and you're going to want to make sure you use parentheses, especially as what's happening in the exponent gets more complex. Now, I'm not going to show you on the video, but you should know on your calculators you're going to type in 2 caret to the negative 3.1 power. We're going to round your answers to 3 decimal places. Okay, so when I type this in the calculator and I hit enter and I round it, I get 0.117. If you have a calculator at home, you can try that. If not, we can do it in class tomorrow. It's not that big a deal. Example 2. Again, I would type in 0.6, and in this one, I'd have to do caret, and I would do parentheses, 2 over 3. You can use the fraction on the calculator, and then you would hit enter and round to 3 decimal places again. I would get 0.711. All right, so that's simple. You will have some evaluating on your homework, so you'll want your calculators. All right, so for each one in the next section, you're going to need to create a table and graph it, but let the calculator help you if you're having issues with exponents. Now, when you're graphing, I want you to do some points to the left, some points to the right of the y-axis. So I would do -2, -1, 0, 1, and 2. Now let's think. If I plug in -2 for x, I have 4 to the -2 power, which is 1 over 4 squared, which is 1 over 16. It's a very small number. -1 power equals 1 over 4, so 1/4. 0 power, anything to the 0 power, recall, is a 1. 4 to the first power is 4, and then 4 squared is 16. So if I look at my points and I graph these, this is very close to the y-axis, or the x-axis. At -1, it comes up just a smidge. At 0, it's a 1, which is a very important point for exponential functions on the graph. At 1, it's up at 4, and it's at 2. When you connect the dots, it's going to skip up pretty quickly. All right, so you get the idea. Yes, you're going to have to graph some of these, and you're going to give me their tables as well. But if you need to, use the calculator to help you with your table. All right, the last thing is transformations. We did this with parent functions, just bringing them back in so you can apply them to exponential functions. Things are the same. Okay, for instance, look what's happening to the x. A 1 is getting added. Remember, what happens to the x is a left or right translation. So what's happening to my exponential graph is it's a positive, which means it's going to move it left 1. Okay, so what I want you to do today in the homework is you're going to tell me in words what's happening here, and then you're going to graph it using your calculator. Just type it into the y equals and find the graph and sketch it on your paper. Example 5. Tell me what's happening. Well, nothing's happening to my x, but the whole thing there's being subtracted by 2. So if you remember transformations, that means it's going down 2. The whole graph is shifting down 2. Example 6. Nothing's happening to x. However, there is a negative sign right here, and that means it's reflected over. If the negative is on the outside here, that means it's reflected over x-axis. If it's happening to the x and the power, that's over the y-axis. So I would say reflected over x-axis. Type that in your calculator, sketch that graph, and you'll see what we're talking about here. And example 7. Okay, what's happening here? Now be careful. Anytime you have a negative happening to the x, you want to take a step and factor that negative 1 out, because that's going to change this direction right here. Right now it looks like it's moving left 3, but if I take that negative 1 out and factor it out, I have x minus 3. What really is happening is it's moving right 3. It's being reflected, that's the negative, over y-axis, and it's moving to the right 3 units. Okay, so anytime this portion is negative, you want to factor out a negative 1 to know exactly which direction things are going, and make sure to indicate the reflection. All right, so on the whisk, you're going to tell me in words, what are the transformations happening to this exponential function? Good luck and see you in class.